This is the Gradle Recipes for Android talk. I'm going to discuss the Gradle build tool specifically as applied to Android applications. This started being the tool of choice back at Google I/O in 2013, at which point Google announced they were moving away from what we would call an IDE build, where everything was done inside Eclipse with the Android developer tools, into an actual formal build tool. Now, the open source community had provided various Maven plugins and things like that, but there had never been anything officially supported and endorsed by Google until that point. Now, by the time we hit roughly 2014, during that year, everything went 1.0, became official and usable, although I got to say Android Studio, which was announced at that same conference, became usable very quickly and surpassed anything in the Eclipse developer tools definitely within that year. By 2015, Google was willing to admit that they were no longer going to be supporting the Eclipse build tools, the Eclipse Android Developer Tool plugin, and that everything was going to be done with Android Studio from then on. And that and Gradle support came at the same time. They grew up together pretty much. Gradle, of course, in our community is quite well known to everybody. This is quite the surprise to Android developers, who, while they do tend to have a Java background, don't necessarily have any familiarity with anything from the Groovy ecosystem, including Gradle. Now, there are some cool things you can do with Gradle regarding Android projects that are unique to the build system, that are things that you would have difficulty doing any other way. I want to talk about some of those. I want to show some of the really nice features. I'm going to make the assumption that you are reasonably familiar with Android applications. I'm not really going to define a lot of that stuff. I'm going to focus much more on the actual new features in Gradle to give you an idea what that's about. Just for the sake of argument, and I'm going to update these slides and upload them to the website after we're done just to make sure that everything's consistent. My name is Ken Kousen. There's my email address. It's ken.kousen@kousenit.com. I say KousenIT. My wife says KousenIt. It was her idea. So there's my Twitter handle, homepage, blog, and the code I'm going to show you is on GitHub, almost all of it. I may show something that isn't, but in general, everything is there. My root repository, or my root account at GitHub is github.com/my last name, Kousen. The book that I just completed that's out there is, in fact, here, let me show you right here. It's called Gradle Recipes for Android. It's an O'Reilly book. Eventually, it's going to be hosted on the Gradle homepage, the Gradle.org or Gradle.org homepage, and you'll be able to get the ebook that way. Right now, it's available through shop.o'reilly.com or Amazon. If you do decide to go to O'Reilly, let me give you a coupon code, just for the sake of argument, for your reward for coming here. The coupon code is capital AUTHD, 5 letters, all capitals, AUTHD, auth-D, whatever that means. If you use that, then you get 40% off of books and 50% off of videos at shop.o'reilly.com. Of course, that doesn't work at Amazon, but it works at O'Reilly. You just have to have my book in the shopping cart. No, that's not true, actually. It works for anything at O'Reilly. You're welcome to. I do have a series of video courses there as well, including a couple on Android and several on Groovy and a couple on Gradle for Android as well. So at any rate, the GitHub repository for the book code is off of my root account, Kousen at github.com, and the name of the repo is Gradle Recipes for Android. The code is all organized into chapters. And I have the same app in multiple chapters, just with different features in it. And I've got the book here in its Safari version available in case somebody asks a question and I can't remember the answer. I've got everything in the book so that I can look it up if necessary. Okay, so now with that in mind, let me go back to the presentation here for a moment. There's the list of video courses at O'Reilly. There's the book. I also wrote an earlier book called Making Java Groovy from Manning, which is a Java Groovy integration book, in case you're interested. Okay, moving on. Now, the Android plugin for Gradle at the current time needs to be added using that build script block. I'll show you an example, but you're probably quite familiar with it. You use the build script block to say where to download the plugin. I get it from JCenter, and then you apply it. You can't use the new plugins mechanism with just the plugins block with an ID because it has not yet been published to the base plugin.gradle.org repository because of certain restrictions that go with that repository. I was talking to Xavier, let's see if I get this right, Ducroet? I mean, I'm probably mispronouncing it, but hopefully that's within a standard deviation or so. At any rate, and he was saying that those restrictions are getting better and therefore they may wind up publishing it there in the future. But right now, you do have to do something that looks very much like this. You have to have a build script block. You put in your repositories, JCentral or Maven Central work fine, and the dependency uses this group ID. This name is Gradle, ironically, which to me suggests that this was written by people who knew Android and not Gradle, because those of us who come from the Gradle world would have called it the Android plugin for Gradle, not the Gradle plugin for Android, right? In other words, this would have been Android. But nevertheless, this is the current version. The book is written on version 2.0.0. In between the time that went to press and now, it's now up to 2.1.2. I've updated everything. Everything in the GitHub repo works, and that's what I'm going to use today. There's the name of the plugin. At least that fully qualified name makes some sense, com.android.application. Now, once you add that, then you wind up with an Android block inside of your build file where you can modify all the properties and do all kinds of things you want to do. And I'd like to demonstrate that right now. Now, I have multiple projects I want to demonstrate. By the way, you see how that is showing up, in yellow now? That's the Android Studio icon. They just changed it. If you are using a stable version, that icon is in green, and if you're using a beta or canary version, then it's in yellow, so that you can see from the icon which one you're using. Kind of amusing that they just did that. This is the canary version, 2.2 preview 4. I updated it this morning because YOLO and all that, you know. I'm going to live dangerously here and just see how it works. But I did try out some things and they seem to be working. Now, say I wanted to make a brand new application. Let me just make one and then delete it. So if I make a new project, which I'll call, Gradle Summit app or something, and I put in my domain and I'm putting it under a standard location, doesn't matter where. When I say next, I have to pick the minimum SDK level, as you can see here. I've got API 16. I usually use 16 or higher. If I can use 17, actually, in order to use Java 7 functionality, like try with resources or any of those, or the new I/O packages, you have to use 19. Those don't run earlier than KitKat, for example. The Java 8 stuff that they are toying with adding in Android N is even newer than that, and even that doesn't support the streaming API or any of those things. So, any rate, these are all governed by the min SDK level. I'm going to just pick the default here. I'm going to go ahead and hit next. And now it's downloading everything. And when I hit next now, and I'll put in an empty activity, I'm not actually going to do anything. I'm just going to select all the defaults and show you what the build file looks like when you do that. Now, one of the things you rapidly find out is that the new approach to Android applications makes every application a multi-project build, so that I'm letting it complete the build at this point. There is a view here called the Android view in Android Studio, which is fine once you're really comfortable with Android, more or less. I'm going to go to the regular project view, which is what most people would be familiar with. At the top level, I have a settings.gradle, and you see it just indicates that the app subdirectory is the actual application directory for the app. If you use an Android library, or if you add an Android library to an existing project, that's a new module in the IntelliJ sense. It would simply add another include to this file and be another sub-project. Then you could use all projects or sub-projects in your top-level Gradle build, should you choose to do so. Speaking of the top-level Gradle build, let me make this full screen, make this a little bigger. Here's my build script block with repositories, again defaulting to JCenter. Here is the plugin being added to the class path. Right now, apparently, the wizard is using 2.2.0-alpha 4. We have an all projects block that adds JCenter as the repository for your app. And it would also be used for any other modules for example, other Android libraries. They also added a clean task of type delete that, in addition to cleaning the build folder at the inside the app, also deletes the build directory at the top level app as well. So these are all there. You're welcome to add things. Of course, they do put the warning here. Don't put your application dependencies here. They belong in the individual module build.gradle files because, again, this is the build script for the top level. This is simply importing the Android plugin. Now, the other build.gradle file is under the app. So let me show you that. And you can see that there's where the apply plugin statement normally goes. If you're doing a library app inside of Android, then it's a different package. It's com.android.library instead of com.android.application, but it's the same overall plugin. Then let me skip the Android block for a moment, and you see here they add in a series of dependencies. They always wind up including this file tree dependency because back in the old Eclipse days, there was no way to do dependency management right in Eclipse or using those standard tools. So instead, you had to download any dependent jar files and drop them in a lib folder. So here they are saying if you have a libs folder or libs folder and you have a series of jar files, this automatically is set up to include them in the file tree dependencies starting at that directory. You can leave that in or not. The standard layout I don't even think has a libs folder anymore, but you can add one if you want. They also have compile dependencies on the app compat library specifically used for material design as well as backward compatibility with older versions of Android. Looks like they threw in the constraint layout, the new feature from Android N that's in alpha version right now. There's a test compile dependency on JUnit. I'll come back to that. And then now they've gone to an Android test compile, which is bringing in Espresso Core. Espresso has been a library for testing, I could basically call it functional testing of Android apps for some time now. About a year or so ago, it was incorporated into the actual Android support libraries at Google. So I would argue that this is an officially supported testing library. I'll demonstrate an Espresso test later on. And they put that in there with excluding the support annotations for some reason. That's interesting, and I'll show you that later. Now, of course, the fact that we're using the Android plugin means we have a whole new block inside here. There's the Android block where you list the compile SDK version, the build tools version, and then default configuration lets you put in your application ID, what they used to call the package. It is now the application ID, the thing that must be unique within the Google Play Store. Min SDK version you could modify here. Target always defaults to current. Version code and version name are used by you to set up the versioning of your app. Version code is used in the Google Play Store. If you increment the version code by 1, that's yet another clue that the app you're deploying is a new version of the same app rather than a completely separate app. You also have to put on your digital signature with the same key in order to make that work. Version name is purely internal tracking. They also added as a test instrumentation runner the Android JUnit runner. This is necessary to work with Espresso as well as other things. So, by the way, as I say, this is brand new. I just created this. They didn't used to add any of this Espresso stuff in the Android JUnit test runner. I have it in my app because I'm doing some testing. Now, apparently, they had generated on the default baseline app. The rest of this app is normal Java code and with the normal, quote, Maven-like project structure. What I mean by that is that there is a source main Java folder with the package in it, a source test Java folder with actually an example JUnit test. Addition is correct. Assert equals 4, 2 plus 2. That's in there. And then there is the source Android test Java package, which is where the actual Espresso tests, among others, go. I'm going to demonstrate tests both in Espresso as well as another library I happen to be fond of called Robotium. I believe that's how you pronounce it. And there also are other testing libraries that come with the support lib. So there's your basic structure. Apparently they do have a libs folder now, but that's all I want to say about this one. In fact, I'm going to close this particular project and go to things that I've already written on there. Now, here in the slides, I mentioned version code and version name. There's also a Gradle.properties file, which is very useful as a way to externalize some of your existing properties. By default, you get build.gradle and settings.gradle and build.gradle inside the app as well. You can add other libraries and so on. Now, one of the things that happens, of course, is that Android Studio, not necessarily of course on this, also generates a Gradle wrapper. Android Studio has Gradle bundled into it. So if you're an Android developer who doesn't know anything about Gradle, like so many of them are, they don't have to download and install Gradle. Android Studio includes it, so whenever they generate an Android project, Studio generates a Gradle W script and a Gradle W.bat script, both inside there. Now, if I take a look at mine, this is just a different application, not particularly that one. There is a, let me show it to you in the project layout. So here, in fact, is my Gradle W and Gradle W.bat scripts. There's also a folder called Gradle, which has a folder called wrapper that has the minimal wrapper jar in it, and then the file they care about, which is Gradle wrapper.properties. This file has various settings on it, but the one that matters is the distribution URL. This is the location where Gradle will download, or from which Gradle will download the Gradle wrapper itself. This is true in any Gradle wrapper distribution, not just Android applications. But when you first load an Android application, it may say to you, hey, you're not using the source distribution. Do you want the sources so you can control click and everything? What they're doing is that when you first load it, and I probably shouldn't have closed that other one so quickly, you get a bin distribution here rather than an all. And if you just if you say, yes, I want to use the source distribution, it just changes the bin here to an all. If you miss that opportunity, you can go in and edit it yourself. Not a problem. Now, if you need to change the Gradle distribution, one way to do it is go right here and modify this. You see how this is currently using Gradle 2.10. Now, if I say go to the terminal, and I'm opening up a terminal in this application, then I can also just say, well, let me use the /Gradle W wrapper. I'm going to run the wrapper task with --Gradle version, let's say 2.12 or something. And when I run that, it's going to regenerate the wrapper. And when I look up here, notice how that changed to 2.12 and went back to bin again. So that if I reloaded this, it would say, oh, do you want the source distribution again? The other way to make the modification is, of course, if I go into either of the Gradle build files here, let's see, here's the top level one. See, you can configure the Gradle wrapper to use distribution with sources. It will provide an IDE, blah, blah, blah. I say, okay, apply suggestion. And then when I look back in that properties file, as soon as that's done, come on, you can do it. Okay, I promise I won't do that again. At any rate, now you'll notice it's an all distribution. Okay, so now if I go back to the top level Gradle build file here, I can always do this. I could always say, well, let's add a wrapper task myself. Oops, sorry. I'll say task wrapper of type wrapper. Oops, sorry, TYPE. Gee, where's all this great content assist? Oh, I'm using Groovy. Sorry. Any rate, then you could just say Gradle version equals, and if I went let's go all the way to 2.14, and now I could generate it again from the command prompt, and I do use the command prompt a lot. I really like it, but there is a Gradle window over here with all the jillion tasks that are involved here. There's also a refresh button you can use in case things get out of date, and I believe it's under, yes, I'm sure. Okay, sync now if you like. I think it's under install? No. No, not other. That's the reason I don't like using, the heck with it. Here, the window there, it's because everything is sorted the way I said. If I just run /Gradle wrapper, actually I don't even know that I need to. Did it update it when I told it to refresh? No, it didn't actually. So let me run it here. Starting a new Gradle daemon, and that should be finished in a moment. And now it's updated. So any of those are mechanisms where you could update the existing distribution. I don't normally worry about it. I haven't done it very often, but I have some particularly old Android applications where the Gradle version was a 1.x, and those don't even compile when I load them. They just break, and where I can't add a wrapper task because it can't even parse the build file. You know, it just gets too confused. And in those cases, I go right to that distribution URL and change it to a 2 dot whatever I want, and then I can rebuild, and I never have any trouble after that. So it's just a nice thing to know about. Okay, back to the slides here for a moment. At any rate, there was the Gradle wrapper command as well as the wrapper task, and there's the actual edit that you can do of the property itself. Now, one of the things that Gradle does that the old build mechanism was unable to do was to work with what they call variants. A variant is a combination of a build type and a flavor. Now, build types, they come with 2 default build types, one called debug and one called release. And flavors we'll talk about in a moment. But the idea behind build types is that you are building the same application just under different mechanisms. So debug and release makes sense. And you can configure certain properties under debug or release if you want. Now, for example, the properties that were set in this particular project under release, they happen to specify, and I left these as the default, minify enabled is set to false, and also the location of the ProGuard files in case you are intending to use ProGuard to do obfuscation and minimization of your code and everything. Here, basically, I'm not doing any of that. There are other properties you can set as well. If you don't have anything to change other than the default, you don't need the block at all. You can also add a debug block. The reason I would add a debug block and a release block is that you can change the values of certain parameters to be read out of the config file, out of a signing config or things like that, and you could put different values under the different blocks and they will be used correctly. You can also add in your own build types if you want. I'm not going to spend any more time on build types. We don't have a whole lot of time, so I'm going to go directly to flavors instead. Okay, but that is available. Now, what's a flavor? A flavor is essentially the same app, just designed for a different client or a different purpose, slightly different changes. The example that they suggest in the documentation is paid versus free. But I'm not wild about that distinction because paid for me and free for me, those could be very different applications. I mean, they really could be radically different unless you designed your app so that turning an app that's free into paid involves flipping a switch, you know, that everything's already in there, then they're very similar. But that's an assumption. I mean, it's essentially the same. Instead, what I like to think about is the same app with essentially a different skin for different clients. So I'm going to show an example of that. Now, for this particular one, I don't have the flavors in. Oh, here's my product flavors. I do. This particular one, I have 3 product flavors. This is actually basically a Hello World app. It's kind of a Hello World app on steroids. It's got a lot of different features in it. But I put in 3 different flavors: arrogant, friendly, and good old obsequious. It's a good word. Just rarely get a chance to use it. So that what's going to happen is that the app will greet the user saying hello, and the greeting will either be very arrogant or very friendly or very obsequious, very humble. By making those separate application IDs, I make it so I can install all 3 on the same device at once, so that they can all live there together if I want to. Now, I didn't set any other properties, and in order to make this work, all I had to do was put in the structure. I didn't have to set any properties at all. And then the way the source code works is that inside app, I now have a source arrogant Java, as well as a source friendly Java, and a source main Java, if you will, and res, see the resource folder, and finally a source obsequious one. Now, in this particular app, I didn't change the Java code on any of these, but I did change the strings XML, and I changed a drawable to put in a different animal. Now, over on the left, they add in a build variance window so that you can say which one of all of these variants you want. So if I do the arrogant debug variant, for example, and I say, okay, I want to deploy that, and I'll just pick one of those and wait for it to deploy, then I will show you. I'll flip over to the emulators. Now, while we're waiting, when Android Studio went to 2.0 and they added the really nice instant run capability, they also added in a much, much faster emulator. Much faster to start up, much faster to restart and to use. At the moment, I'm not using it because I got used to using some of these Genymotion emulators, and if I have to run multiple emulators, like I want to do here, I want to run 3 of them at once. Let me just make sure it's running. Oh, did I just run the wrapper task again? No. Wait a minute. Where's my... Oh, it's still thinking. That's what happens. I keep switching apps and switching APIs. At any rate, when I want to run multiple ones at once, sometimes it takes less memory if I just start up multiple Genymotion ones. Now, I'm using the free version of Genymotion. That's G-E-N-Y Motion, if you're not familiar with it. It is a commercial quality emulator that is very powerful and sophisticated. Now, that's taking too long. So what I'm going to do is, if I can stop that. Now, that's not running here. That's in my run window. I think I can stop it. And instead, what I'm going to do is I'm going to go to my Gradle build file. Okay, I've nicely broken it. Let me switch to a different one. Okay, this is a much bigger one, but let me show you pieces of this as well, where I have multiple flavor dimensions this time. What I'm going to show you when I go back to that other one in a moment is that I'm going to show you that by using Gradle, I can install the apps on all connected devices simultaneously, so that I don't have to wait and choose a particular drop-down anymore. I can just go, oh, install debug, and they're installed on all of them. Let's just make sure that, has that woken up yet? I do seem to have nicely broken it. That's pretty good. And I don't think I can close it or anything, right? I think it's going to be, oh, it did close. Okay, let me see if I can get it back real quick. And I'll make it in a new window. And it looks reasonably happy. Okay, good. So one of the tasks under Gradle, if I look in the install block, is you see once you start using flavors, you get huge numbers of combinations. There's arrogant debug, there's friendly debug, obsequious debug, as well as the arrogant release and friendly release and obsequious release. You get all of these uninstalls and installs. By the way, what you didn't see was an install arrogant release, because you need a signing configuration before that shows up. You can't install any of the release versions until you put the signing configuration inside the build file. If we have time, I'll show you that. Now, there's an uninstall all here, which works. So if I say, for example, Gradle W uninstall all, and I'll just abbreviate using the camel case and everything, then it should go through all 3 of my emulators and run on all the uninstall tasks on all of them. So this way I guarantee I don't have them already existing on any of the emulators. So you see I'm clearing them out completely, so I don't have to worry about them. Now, there is no install all, but I've added a variant here that I wrote called install debug flavors. Again, since this is a Gradle audience, let me focus on that sort of thing. When you make your Android app, there is a reference called Android that has a property called Android variance. There's also Android libraries and Android tests. But if I go to Android variance and say for each one, I use the all block here. I said if the variant name, now here, let me show you the variant name. See, I have a print variant names that says on all of those, just print the name. So let me run that, and I'll go /Gradle W PVN with the capital V and the capital N here. Trying to make that a little bit bigger. And you can see there are all the combinations of the flavors with the release types. So they're all there: obsequious debug and release, arrogant debug and release, friendly debug and release. The variant exists even if I can't install it, because I don't have an install for that yet. On the other hand, on this install debug flavors, I'm saying if the variant name ends with debug, then I'll change that name, I'll capitalize the name, and then I'll say there's a task called install that name. So this one that says arrogant debug here with a lowercase a, I'm now going to say make a name called install arrogant debug. Actually, I'm going to say this task depends on that, so that it will create all of these tasks dynamically and then run them. Show me Kotlin doing that. No, I'm sorry, I can't resist. So at any rate, if I now say Gradle W install debug flavors, I could have abbreviated that as well. Then it's going to go through the mechanism to generate the APKs for all 3 of the debug flavors and install them on all 3 emulators. And it's cranking through right now. So it's done the arrogant ones and the friendly ones, and now it's doing the obsequious ones on all 3. And if I go to my emulators here, actually I can go right to that one. Then if I look inside the settings, you'll see there's my arrogant, there's my friendly, there's my obsequious. So if I run it just to show what it looks like, and I put in hello Dolly, I say hello, that's the arrogant flavor. We condescend to acknowledge your presence if just barely, Dolly. And if I put in the friendly flavor with that as well, then there's my friendly one. We're BFFs now, right? And in case you were wondering what obsequious meant, then there's my obsequious one. I put in Dobby. That's the most obsequious thing I can think of. I shouldn't say this on the video, but the picture is in the book. I'm waiting to hear from the Harry Potter people, but hopefully that falls under fair use. Well, we'll see. Any rate, that's how easily you can write flavors. See, that to me makes some sense because it's essentially the same app, just with different look and feel. Now, in addition to that, in the other one that I was trying to show you, so let me go to that other one now, I also have another flavor where I want to say it depends on the client. So I made a flavor dimension called attitude, and that's arrogant, friendly, and obsequious. And then I made a flavor dimension called client, and I have one for Stark Industries and one for Wayne Enterprises. Now in that one, I actually changed the Java code as well. Now, resource files in a flavor overwrite the corresponding, overload or whatever. They override, probably be the right word. Their variation in main. But Java ones, you have to be careful. They will conflict if I have one in main. So I made sure I have the proper classes in all of them. I just changed the implementation of those classes in each flavor. There's various mechanisms for how to go about this on a regular basis. At any rate, with this one, now I have multiple variants, and I could pick like friendly Wayne debug, and let me run that, for example. And then I can also run one of the latest version of incompatible with the plugin being used, which we know is not true. So let me do Gradle W install FWD, friendly Wayne debug, and let Gradle handle all the issues there. And it's going to go ahead and install it on all of them. And when I go back to the app, then you'll be able to see the variation here. Here it is on the middle one. And whoops, I hit the wrong button. Let's try, now which one did I do? I did the friendly one, right? See, this says Wayne Enterprises, please enter your name. And I could say hello, but that's just the arrogant, friendly stuff. But here's your call for help, and for legal purposes, we know nothing about mass vigilantes, etc. So I have a Java class with a fragment in it to do this part, whereas if I then go and say, all right, back to here, let me install instead the obsequious start. No, Stark's got to be arrogant. Stark debug. Then when I run that one, again, it's installing it on all the APKs. And by the way, you see an advantage of Gradle? Android Studio got confused about what was and was not okay. Gradle was still able to run from the command line. Okay, not a problem at all. So let me go back to where I was, and I'll run the obsequious one. No, it wasn't the obsequious one. Pardon me. It was the arrogant one. And you see there's Stark Industries, and in this case we put in, a drop-down list. You could hire Tony or contact the Avengers or whatever you're interested in doing. I do apologize for my sense of humor. But the point is you could change Java classes, you could change resources, all these things inside like this. So I've shown you a couple of custom tasks. I've shown you a bunch of flavors. I've shown that you can install and uninstall all these things simultaneously on all of them. The other thing I would like to show you is the testing part. And this is one of the coolest features of the Gradle implementation on top of Android apps, is that you can run all of your tests on all of your devices, connected devices, simultaneously. And it's really cool to watch, actually. So let me go back to one where I don't have too many of them running. I don't want to run a zillion of these things. So I believe this is the one I want. Let me make that a little bit bigger. I am in the install branch here, and you can see that I have a series of tests. Now there is a basic application test that uses application test case to just say, hey, it got loaded at all. Nothing special on that. I have this thing called a database adapter test that extends Android test case. I have my own database adapter in here saving the names that I greet each time. And the nice thing about this one is that there's no visual element to it. Okay, you don't actually see any changes, and this is not an instrumentation test case. This is testing some, I don't want to say services because it's not a service, but a supplementary class that doesn't have any visual part in it. Then I have the following. My activity layout test is using the Google JUnit 4, see the Android JUnit 4 class here? Activity instrumentation test case 2 on my activity, and this one allows me to basically check that all of the layout is correct. I'm not actually doing anything on the layout. I just want to make sure that the buttons are where I expect them to be and the fields are where I expect them to be and they have the right settings on them. So I have attributes here for the activity, the text view that says hello, the edit text where you put in your name, and the buttons that you click. And in my setup, after injecting the instrumentation, I get the activity and look up all of those widgets using the good old find view by ID. Same thing you would do in any other case. Then I have test. I call this test preconditions. I got this from their documentation. This one isn't anything special. It just checks to make sure all those things aren't null. But the benefit to it, of course, if this test fails, they all fail. And I'll know why. You know, I'll go, oh, I get one of these was null, and therefore everything is wrong from that point of view. So I'm not running these in any particular order. I just like having a diagnostic like that. Then the rest of them are doing things like, oh, text view, get text to string, and here's the actual text, which I'm actually getting from a string resource. And I'm able to compare those two and make sure they're right. And I'm doing the same thing on each element. So this is the label on the text view, the hint on the edit text, the label on each of the two buttons that I happen to have here, all available. So this is a regular test, but it's just testing things that are static. I'm not actually manipulating or clicking any buttons or filling in any fields on this one. To do that, I have two approaches. One is this Rebodium one, and one is the Espresso one. So the Rebodium one has a class called Solo as part of Rebodium. I'm always tempted to make this reference Han or Hope or even Soprano, but I just called it Solo. And here in the setup method, you instantiate it, just using the instrumentation and the activity. And then I'm able to do things like assert that the current activity is the correct class, and then enter text in the 0th text element, dolly, click on the button that says say hello on it, assert that the current activity is now the welcome activity, and search for the text hello dolly, and then shut everything down. So this is just a regular functional test using their API. Okay, so this is what I used until Espresso started becoming popular. Here's the same basic idea using Espresso. Once again, I extend activity instrumentation test case 2 with the activity. This time you put in a rule that says I'm using my activity in the activity test rule, and then here's what Espresso tests look like. These are all static methods. If I opened up my imports, you see I have a ton of these import statics from Espresso. So on view and click and type text and matches and all those things are in there. So I'm basically saying on view with ID, r.id.edit text, perform type text dolly. On view with ID hello button, perform a click. And then on view with ID greeting text, check that it matches with text hello dolly. Now what's interesting about this, by the way, is that in my app I actually change from one activity to another. When I click on the button, the Espresso test doesn't know or care. They're just looking for a result. The Rebodium test, I verified that I went to the other activity. Okay? So I don't have a ton of tests, but I've got all of those. It's not zero. It's got something. So now I'll go to my terminal, and this time I'm going to say Gradle W connected check is the phrase I want to use. I'll write it out. Connected check. And then this will run all the tests on all the emulators simultaneously. So I better get them over here. So, oh, there you see them flashing by one. This is the simpler version without all the flavors in it. I just wanted to run all those tests and everything. And you can actually watch it do it, you know. Now, the database test is running too, even though that's not visual. But isn't it nice how it's running on all the devices at once, this way, and now it's done. And then if I look inside my app, build, reports, tests, or Android tests, pardon me, connected, then I can go to index.html here. I didn't mean to say LF, I meant to say open. Just a minute. And now you can see I ran 39 tests. These were the various classes they were in. And if I pick a specific one, like the espresso one, you see things are ordered by test hello world on each of the 3 devices. Or I could click on the devices tab and see them ordered that way. So if I went back to, say, the Robotium test where I had multiple tests in there, you could see again, there's the mechanism. There are 2 tests ran on each of the 3 emulators, and it would also run on any connected devices I happen to have plugged in, although sometimes the communication gets a little dicey. Sometimes things will fail just because it didn't communicate it correctly, but the emulators seem to work beautifully on this. And isn't that nice? I mean, you saw how fast that was to run. The other thing I could say is when you run tests with flavors, you tend to get special subdirectories for each flavor, but there's also a test report plugin which gives you a merge Android test command that lets you merge all those test reports into a single output. And that's nice too. And if I go to the one that has all of my flavors in here, and I believe that's this one, yeah, this has all the different flavors in here. I believe it put it under the top level build, reports, Android tests, index.html, and this is the kind of test report you get. It's not as not quite as big as the other, but notice that on each of these, sorry, let me go to any of them. You see now I have a tab called variance, and it's showing all the different variants too. And because I used that merge report, I was able to get them all on one test output like this, which is really nice and really under-publicized, you know, inside the documentation. All this stuff's in the book. The merged report, I always have to look that up. So another reason for writing the book is so I'd had it written down somewhere so I could go find it. Okay? All right, with all that in mind, let me summarize what I've been doing here. Oh, wait, it's right here. So there's your build types. Every time you make a build type or a flavor, you get an extra source distribution or a source tree, if you will, with those names or those and an Android test tree. The resources in the build type source sets replace their counterparts in main, but Java classes conflict. You have to be careful with that. You can't assemble a release until you sign it. I put in the slides that you could run Java's key tool to generate a signature. I know that's just a self-signed certificate, but remember the purpose of the signing the jar file here is not security, it's what they call non-repudiation. When you upload your app to Google Play, they want to know who to blame when things go wrong. And by putting in your own digital signature, then you can't say you didn't sign it. You know, it's non-repudiation. They could also tell that it has not been tampered with in transit. But it's not about encryption, it's about non-repudiation and integrity. At any rate, this is an example of running the key tool, generate the key with here's the key store I want, and an alias, and an algorithm, and the key size and validity, and you fill out the little form, and it generates it. And then inside your app, inside the Android block, you put in a signing configs block. This is what the release block would look like with the file and the alias. And if you're uncomfortable putting the passwords there, remember, you could put those in Gradle.properties if you want, and even override those values by specifying them on the command line with a $P argument. So you don't have to hardwire them in here. The passwords, yeah, I mentioned, they could be external to the app, and then inside your build type, you point out which signing config you're using. And incidentally, Android Studio has GUI parts for all of this as well. You don't have to remember all the terms inside Gradle build. They have a UI where you could actually go in and set them there. There's a signing report task to show the details. Let me skip some of this. Here's my various flavors. And there's the multi-dimensional flavors, flavor dimensions with both. And here I put in a custom task just as an example of doing a copy task to copy all of the APKs, not the unsigned or the aligned ones, copy them all into a particular folder. Again, just using Gradle's built-in copy task to do that, as opposed to this, which used the Android application variance tree in order to print all the variant names. And then I showed stuff about the unit testing and the functional testing as well, running on all simultaneous devices. The tests go under the Android test Java area, and you could run connected check to run them all, and there's just some references at the end. So I wanted to give you all that. I will hang out if there are any questions for a few minutes, but otherwise let me just say thank you very much for coming.